Hello everybody, this is Richy, Communications Lead at Nimiq. Nimiq recently transitioned from Proof of Work to Proof of Stake, and to talk about that, I'm here with Philipp, blockchain engineer of the team, and with Basti, also blockchain engineer of the team. Guys, how are you doing?
Doing great. Thanks, Richy. Feeling good today.
Okay, guys, so let's start by talking about the migration itself. I know that you planned this a lot, that you did a lot of tests. Do you want to go a little bit into what kind of tests did you run, and maybe some suggestions to people also working on testnet proof of stake implementations?
I mean, amongst the tests that we did, obviously, a bunch of test migrations. So as one of the main focuses that we did. Then the migration tool itself, exporting the state and then comparing the state to what you would expect to find. But even in the very last days before the migration, still also run the migration tool and get a new Genesis block going. So we actually kind of started proof of stake chain mainnet maybe 6 times. And then discarded all of these early chains, and then obviously started the actual one at this point, I think 2 days ago.
Can we go maybe like a general explanation of how the migration happened in terms of the different phases and all the process that went into it?
Sure. So the migration is a long process which ultimately concludes with the migration candidate block, which we now have also adopted as the Genesis block for the proof of stake chain. And it begins months earlier with a validator pre-registration, where all of those validators who are now currently producing the chain and have been doing so since the Genesis block have registered on the proof of work chain in a very defined manner, such that the tool that we provided can generate a Genesis block with those or where the elected validators are chosen amongst those validators. So that has happened, I want to say 8 weeks ago or 9 weeks ago or something like that, which was the first phase of this migration process. And then pretty much right after this phase concludes, the pre-staking phase begins. And within this phase, users on the proof of work chain were asked to pre-stake their NIM and delegate it to one of the validators of the pre-registration phase. And we reached an incredible, like almost 50% of the circulating supply on the proof of work chain being pre-staked for validators, which was really awesome to see. And that process basically continues throughout, I believe, a little bit over a month until last week, within which then the final set of validators and their respective stake is known. And after that, we really just take it a little bit slow and like make some sanity checks and make sure that everything works. But the state of things has already settled. And then 2 days ago, the migration script for all of these validators who now need to run this activates one predefined block as the migration candidate. And this process could have taken a couple of days, where multiple candidates would be chosen one after another, depending on how the validators react to the block that they have produced. But for us, this worked in the very first attempt, and thus the chain was then started with that set of validators active. And that happened 2 days ago. It was amazing.
Thank you. And Philipp, you were there, of course, in the launch 2018 of Nimiq Proof of Work. How would you compare it, the launch of a new chain back then with now a migration from Proof of Work to Proof of Stake?
Mm-hmm. It felt very similar, to be honest. So the very similar sense of excitement and adrenaline was manifesting on the day of the migration. I feel that the migration was more complex and more involved than the start of the initial proof of work chain, which pretty much involved publishing the Genesis block on GitHub, which was the signal for all miners to start. And since in proof of work there's less coordination required between the different network participants, we had a very smooth start of the proof of work chain. Proof of stake also the migration worked really well, apart from minor configuration issues with the seed node. But that also showed that the client is actually working really robust. So even without the seed node, the network was able to establish itself. And as soon as sufficient stake was online, the chain started running without further intervention. So yeah, very similar feeling between the original launch and this migration. But overall very positive, and very relieved that this step has finally been achieved.
And when Albatross, the consensus algorithm being used for Nimiq proof of stake, was first published, it mentioned this is an optimistic consensus algorithm, right? Would you like to elaborate a little bit on that and how this consensus approach maybe required a little bit more fine-tuning from the paper to the actual implementation in the chain?
Sure. So this is Albatross is a hybrid approach where we are able to produce blocks very quickly by having just one validator propose them in a round-robin fashion, in a randomized round-robin fashion, basically. And that allows us to produce blocks very quickly because there's only one signature required to produce a valid block, as opposed to having every validator sign off on every single block. So this is where the optimistic aspect comes in, because we rely on validators or the single proposer not proposing multiple chains. But if that happens, we basically go into a less performant fail-safe state, so to say, and just skip the respective validator who's slow or not proposing, or maybe proposing multiple chains. So the network can recover from that. It will just run a little bit slower. But even small perturbations in the block grid and the block timing will be we can recover from these perturbations by just running the chain faster for a short period of time to basically get back to the original timing, if that happens. So and I think that also sets us apart from other chains where every single block is finalized and therefore produced slower.
I mean, some of the changes that we made over the years since the white paper includes the skip blocks that Philipp just mentioned, because originally those were called view changes, and they would actually not produce a block, but they would sort of increase a counter that we use to produce the next block that is still on the same height. But now the skip blocks have been introduced, I want to say maybe like 2 years ago. And that is one of the changes where we realized that it is very beneficial to persist these kinds of information to the chain, so that we don't lose that progress that we have already made with these votes of the smaller fail-safe fallback that we are now using. So that is one of the changes that we made over the years to make this a little bit more performant or better or more robust, as it originally was maybe designed.
And it is based on Tendermint. If you would compare it with the Tendermint implementation and our version of Tendermint, are there any different additions of things that you needed to look into?
So the protocol itself is not exactly based on Tendermint, but we have one sort of sub-protocol for producing macro blocks, is what we call those. And that is based on Tendermint, and the Tendermint implementation itself, I think, is very similar. However, what we do use is an aggregation scheme that is different from what Tendermint uses, and we use Handel in our network to aggregate signatures more efficiently and more quickly, both in terms of network complexity, but also in terms of computational complexity. So in both of these metrics, this aggregation scheme fares better than just aggregating everything up, which in a network where there's more validators than we currently see, this would result in a like more pronounced performance increase that we would see over like conventionally just aggregating everything up that is gossip to us. So that is one of the changes that we did, and so far that also works quite nicely, and we're fairly happy with it.
Thanks. And when talking about the protocol, let's talk a second for what happens or how is managed the malicious behavior of validators and unexpected behavior of validators, like going offline, for example.
So, yeah, I think I already mentioned earlier that with a single block proposer, there's the potential for this proposer behaving maliciously, for example, by proposing multiple chains. So there are different levels of penalties that we have for validators. The lowest level, which we also call just a penalty, is applied when a validator misses producing a block. So if he's selected as the next block proposer and the block is not proposed within a timeout, then the rest of the validators will vote together to skip that proposer, which will then lead to this validator being deactivated, which means that he will not be selected to propose any blocks anymore starting from the next batch. It will also cause this validator to lose the reward for this particular slot that he missed to propose in. But we allow the validator to reactivate, so to come back into the slot selection rotation by sending a corresponding reactivate transaction. So this is geared primarily against protecting, or this is geared to protect against offline validators slowing down the chain too much. Right? So if they keep missing their slots, they are deactivated and they're not going to be picked anymore. And then there's another category of penalties which are punished more severely, and that is whenever a proposer or any validator votes or proposes conflicting states. So, for example, if the block proposer proposes two blocks which are both correct but are not equal, then it's ambiguous which chain is the correct one, right? And we will require another validator who is benign to sort of resolve this fork by picking one of those competing chains. So if that happens, a validator will be jailed, which means he will be locked, or his funds will be locked, and the total stake will be locked for multiple epochs, and he will not be able to participate in anything, will not receive any rewards. The stakers cannot withdraw their funds anywhere, but the whole stake of this validator will remain locked until the jail time expires. And this is applied for proposing multiple blocks, voting on different proposals, or they're basically proposing conflicting blocks. That's basically what jailing is for.
Yeah, so the one thing, the multiple blocks, that is basically something that happens with malice of the validator. They need to choose, or a severe bug, but they need to choose to propose two different things for the same block height, for example, or two different proposals for the same macro block, or they vote for two proposals at the same time. That is basically in their hands, and it is like an active process that they do. Whereas missing a block can have any kinds of reasons, only one of which is that they intend to do so. But maybe it's non-intentional, and for that they should not be overly punished by jailing them, for example, for multiple epochs just because they needed to patch their node, for example, and they weren't there for like the 10 seconds that it happened. So that is one of the reasons also why this is a very big difference between those two different punishment mechanisms.
However, even though there are this type of mechanisms, right, users' funds always remain safe, right? Even if a validator misbehaves or goes offline. Would you like to talk a little bit about that?
Sure. So, I mean, Philipp already mentioned that when a validator gets jailed, that the funds of the respective stakers for that validator also get jailed. So they are not available for withdrawal from the validator. They cannot be unstaked within that period, but they will also not be diminished by the protocol in any way. They remain just as they are, and they are safe where they are too. The validator never gets custody over any funds in any way. So users don't need to worry about their stake funds being diminished by the protocol. The only thing that can happen to them is that these funds will be locked in place for some epochs, but after this time elapses, they are free to withdraw again. And the same also holds true for deleting validators. So deleting validators also just leaves something in place which that then holds the user's funds in the staking contract instead of the validator. So something to point these funds to that is no longer a validator, and they can just the same withdraw then at any time. So the funds of the users are always safe.
And in terms of, I know that Proof of Stake just came out, and now is monitoring and mixing some fine tuning. But from the top of your head, what have you thought of maybe adding, working on optimizations, things like that? Of course, no priority list or anything, or nothing promised, right? But things that you have been thinking about. Is there anything that you already are a little bit considering?
I mean, there are a bunch of smaller things, right? No real big issue that we've been putting off after the release, where we are now saying this needs to be tackled now right away. But there are bunch of small improvements, some of which we have already prepared prior to the release. One of them is to make validator address resolution more robust, meaning that it's easier and or better generally for a validator to find other validators to connect to, because there's coordination required between validators, so they need to be able to talk to each other. And right now, the discovery of other validators relies on a distributed hash table, and the current implementation it works, but it could be better. So this is one thing that we've already prepared, to have another channel where these validator records are distributed, so that we don't have to rely on the DHT only to broadcast these. Then, of course, things can always be made faster. So there are some ideas on how certain aspects of the sync can be improved. For example, the validity window sync, which right now downloads up to one full epoch of history. And there are also other smaller improvements that can be done. So these are things that we'll be probably looking into. But yeah, so there's definitely a list, but not the one big issue or the one big feature that we've already planned.
No. But yeah, I mean, I think both the validity syncer and the validator resolution are very good examples of where you can prepare the code in advance, such that the later addition of a feature like this is going to be a lot easier and requires a lot less coordination from the network as a whole. Because what we can do now is we can basically put this new mechanism in place, and those validators that have it will benefit from it, while it will not be to the detriment of anybody else. And so whenever we knew that there was something that we wanted to do in the future, we tried to maybe identify if this can, or like something like this can be done to ease the process of like implementing this at a later point after the launch, and also the first couple of bug fixes and performance optimizations are done. So these will not require a hard fork or anything. We can just focus on that feature, implement it properly, and then just roll it out. And those validators that adopt that, they will then have this to their benefit. And that is, I think, was a very good decision, I think.
And well, this came from testnet and a little bit in the theoretical realm to now something that is a reality and people are using it, and you guys are even using it, right? I understand you're like staking and maybe running a validator. How does it feel like now to have your hands on this thing?
If I'll be honest, it is pretty amazing. So I am running a validator right now, and it's like one of the things that I still like to do is just log into that machine and see the validator produce blocks and realize that that is the chain as it moves is for me personally quite a great feeling. I really like it. Also seeing how the community uses it, how the validator pools are like being implemented and also improved slowly as we speak, and seeing all of our tools come online now to like enable all of the functionality that you are used to from proof of work is just a really awesome feeling. And I mean, I guess the community has been waiting for this quite a while, but believe me, we also have, and it is quite great. It's a very good feeling.
Nice. And then maybe to end, would you like to share something, say something to the community developers, to the people running validators, running pools, everybody out there that also helped make this possible?
I mean, first of all, I would extend my deepest gratitude. They have stuck with us for a long time. There's like some community members, you know who you are, who have been there like forever, basically. And then for now to have pre-registered as a validator, to have staked for all of our validators, to have been there for the migration process itself. It was really an awesome moment for us all, and you were a great part of that. And I think I can speak for everyone that we are very grateful that you were all there and helped make this fantastic memory for all of us to have. So I'm really quite very much happy about all of that. And then let's see what cool stuff we can build with this now. I mean, there's a very fast blockchain now that we can use to build a bunch of cool shit with. So let's do that.
Nice. Okay, Philipp, Basti, thanks a lot. And then see you in the next one. Amazing work with the chain. A lot of people are very happy with that, including myself. So thank you for that. And thanks also from my side to all the community developers, to the pools that are popping up, and all the amazing tools that have been built there. You guys are making this possible, and we're loving it. Everybody in the Nimiq community is loving it.
Absolutely true, 100%. Okay. Thank you so much, Richy, for having us.
Yeah, thank you for joining me.